Understanding Radio, a detailed exploration. Introduction. Radio technology is an essential part of modern communication, enabling wireless transmission of information across vast distances. In this chapter, we'll start by examining a simple radio system model and then expand on its core principles. By the end, you'll have a fundamental understanding of what a radio is, how radio signals work, and how modulation and demodulation enable information transmission. A simple model of a radio system. At its most basic level, a radio system consists of a transmitter, a receiver, and a medium, air, through which signals travel. Consider the example of a car radio. A transmitter, a radio tower, generates a signal and transmits it into the air. A receiver, your car radio, captures the transmitted signal and converts it into sound. The medium, air, allows the signal to travel from the transmitter to the receiver. This fundamental model demonstrates that radio communication requires sending and receiving signals, but what exactly is a signal? Understanding signals. A signal is a variation in a physical property used to convey information. Examples include visual signals, a flashlight turned on and off to send messages. Electrical signals, telegraph systems that use varying current levels to transmit Morse code. Electromagnetic signals, used in radio communication, where information is encoded in electromagnetic waves. In radio communication, electromagnetic waves carry information over distances, and different types of information, such as sound, video, or data, can be transmitted via radio waves. What can radio signals transmit? Radio signals can be used for various types of communication, including audio, music and speech in AM/FM radio, video, over-the-air television broadcasts, control signals, commands sent to remote devices, such as car key fobs, data, wireless internet traffic between devices and routers. To make radio transmission effective, modulation is used to encode information onto radio signals. Modulation, encoding information onto a carrier signal. Modulation is the process of altering a carrier wave's properties to encode information. The two main components of modulation are 1. The message signal, the information to be transmitted, e.g., sound, video, or data. 2. The carrier wave, a high-frequency electromagnetic wave that carries the message signal. The output of modulation is a modified carrier wave that now contains the original message. The receiving radio system then uses demodulation to extract the information from the carrier wave. A more detailed radio model. Expanding on our simple radio model, let's consider how an AM radio station works. 1. Audio signal generation. A microphone or music source creates an audio signal. 2. Modulation. The audio signal is combined with a high-frequency carrier wave. 3. Transmission. The modulated signal is broadcast from the radio tower. 4. Reception and tuning. A car radio selects a specific frequency. 5. Demodulation. The original audio is extracted and played through the speakers. By tuning to a specific frequency, the receiver focuses only on the desired station, despite multiple signals being transmitted simultaneously. Understanding AM radio signals. The nature of a signal. A signal represents variations in a property over time, such as air pressure variations, sound waves, voltage changes, electrical signals in circuits, electromagnetic intensity, radio waves received by an antenna. On a graph, signals are represented with time on the x-axis and amplitude, signal strength, on the y-axis. The AM, amplitude modulation process. Amplitude modulation AM is one of the simplest forms of modulation. The audio signal alters the amplitude of the carrier wave. Higher audio signal values increase the carrier wave's amplitude. Lower audio signal values decrease the carrier wave's amplitude. The resulting modulated signal contains the original information encoded in amplitude. Variations. Visualizing AM modulation. Carrier wave, before modulation a high-frequency sine wave. Audio signal, a waveform representing speech or music. Modulated wave, a carrier wave with amplitude variations that mimic the audio signal. At the receiver's end, demodulation extracts the audio signal from the modulated carrier, allowing the sound to be reproduced accurately. Conclusion. In this chapter, we've explored the fundamental principles of radio. Signals as representations of information. Modulation as a method of encoding data onto carrier waves. Demodulation as a method of extracting transmitted data. AM radio as a simple yet effective example of radio communication. Moving forward, we'll delve deeper into topics such as carrier wave selection, frequency analysis, and other modulation techniques beyond AM. Understanding these concepts is crucial for working with software-defined radio, SDR, and designing modern communication systems.